So our supply of fresh water comes from or can come from three different main sources. So the first one has to do with surface water. So this would be the water that is running off from the ground. So it is above the ground in rivers and streams. In the case of, say, for example, the river that runs through my town, there's actually a lot of water underneath the river that is percolating through the rocks, but it is still running underneath. So it's kind of an interesting phenomena that occurs in the rivers. When we talk about this surface water, we sometimes have periods where we don't get a lot of rainfall. And so one of the things that has been done to allow us to access this water all year round, obviously, is to dam these streams and create reservoirs. So we can dam to create reservoirs. So these reservoirs and the dams could also be used to generate electricity, but they are also a way for us to keep the water where we want it to be so that we can use it for maybe agricultural purposes. The problem obviously for this is that it disrupts the ecology of rivers and streams and has been a big factor in preventing, say, for example, the migration of the salmon back up into the streams for them to breed. We can also talk about diversion. So we could build, for example, canals. So we could take that water out and put it into like an irrigation canal and send it somewhere else. We could also put it into an aqueduct or put it even into a pipe to send and maybe even take out and send to a city that needs it. So this is the way that we use that surface water. When we talk about the other types of water, we have groundwater. And so these could be the type of groundwater that is found in an aquifer. So if we were to look at the surface waters and the groundwaters, based upon the amount that is available, fresh water that's available to the different continents, it's kind of interesting. So let's look at a graph that shows this. So we see the continental water supply, and this is a little bit misleading because in some of these places, like in South America, a lot of the water is in just a few rivers, like the Amazon River, for example, carries a huge amount of water. The black bars are actually populations. I could write that on here. I could say that this is population. So in North America, we have relatively lots of water compared to our population size. But if you were to compare that to like Asia, the population size is much greater than the amount of water available. And so they are going to be water stressed in that region. In Africa, something similar. Notice that in Africa, it is generally in red. That is my groundwater. And then the green is actually the surface water. So we see that in different areas of the planet, those availabilities and the comparison with population differs from one region to another. How do we get access to that groundwater? We need to drill wells. And so one kind of convenient way to drill a well is to tap into an aquifer that is under pressure. So it is a confined aquifer so that the water can't go anywhere and it starts to build up pressure. And so if I were to put like a pipe down into this aquifer, because of that pressure, I'm going to get water just automatically flowing out. And so that we might also view that as like a spring, right? Water bubbling up from the ground. And this is very nice to have. However, you have to realize that you are going to be using that groundwater, and the groundwater is not something that is easily recharged. So if I have an artesian well, I would want to make sure that it is capped and I only take out as much water as I need, right? I wouldn't want it just to bubble up out of the ground because eventually that well is going to run dry, or I'm going to have to put my well, sink it deeper. I'm going to have to drill deeper. We also have most of the wells that we see are actually in unconfined regions, so that we actually have to pull it up. So you actually have to have a pump on your well that pulls the water up out of the ground. Now, another mechanism for getting fresh water, which is a possibility if we start to run out of water, is what we call desalinization or desalination. So this is where we take out the saline. So this is where we take salt water, and from this salt water, we create fresh water. Now, obviously, the hydrological cycle does this for us, right? But it uses the sun to do it. We might need to use some other source of energy. So you could take salt water, heat it up, distill it, turn it into steam, and then capture the steam and then turn that back into liquid water. Now, the problem with desalination plants is that they're energetically expensive. So in order to like boil salt water, I might have to use fossil fuels to do that. And then I'm causing the release of CO2 in the atmosphere. Another way is to use almost like a reverse osmosis mechanism where you use membranes. So you take and you get the water to move out through the membrane, and you collect the fresh water, and then the salts stay on the other side of the membrane. So desalination would be a way, a mechanism, a technological mechanism in order to increase the supply of fresh water that we have.